So we will discuss numericals on curves. Okay, so here we have a question. We are given a curve of radius 400 meter. The deflection angle is 40 degree. Chainage of T1, okay. Chainage of T1. T1 is the first tangent point. Remember that chainage is given, and we have to compute and tabulate the angles and theodolite readings so that we can find the points on the curve, and finally we can set out the curve. So what are the data that we are given? First of all, we are given the radius r of the curve, deflection angle, we remember deflection angle, I hope, and chainage of T1 point. So what is chainage? The road is coming somewhere here. The beginning is not necessary, right? What is the important point? From where the curve starts. So we are calling that T1 point. Okay, from here the curve or turning is starting. That is our T1 point. If the road would have been straight, this would have been the way, right? And this one is tangential to this curve, right? So therefore this is the tangent point. Then the road will go along this way, for example, and if this would have been a straight line, this would have connected like this. So the angle made here, that was our deflection angle. So by this angle, the direction of the road has changed or deflected. So that is why this is deflection angle. This is T1, first tangent point. This is T2, the second tangent point, if we are considering the movement from this side to this side. Then what is chainage? Chainage of this point is given. That means the calculations or the survey work started somewhere here. We don't know. Okay, we are coming 100 meter, 200 meter, like this. We are coming and coming, carrying out our work. And what is the value here? That value is the distance from the beginning of the work. So that is our chainage. So if we go back here, what is the value that is given to us? Chainage is 1804.25 meter. So this data is given to us. So from here, we have to find out the different angles that are going to be there in our curves and different points. So we have formulas to find out the length of the long chord, the length of the curve. Now, what is the long chord? So we have a formula based on this radius of the curve, because radius of the curve is what? This curve is a circular curve, and therefore it is an arc of a circle. This is a part of a circle, okay? And it will have some radius. It will have some radius, 200 meter, 300 meter. It will have some radius. In this case, we have a 400 meter radius. Okay, so this is a radius. Now, depending upon radius and this deflection angle, we have formulas with which we will be able to find out what is the length of the long chord. This is the long chord, the straight line joining T1 and T2 point. T1 and T2 are tangent points. So joining them is our long chord. This is the circular curve. The portion of the curve is the length of the curve that we can also find out with our formulas. So if we go back here, so here we have formula length of the long chord T1, T2 twice r sine of phi by 2. What is phi? Phi is the deflection angle. Okay, at some places it may be written as delta. It does not matter. So twice r sine phi by 2, that will give us, okay, this is the length of the long chord. This is a straight line. Then length of the curve. Then again, here again, we have formula. This formula is the basic formula of finding out the length of arc of a circle from the radius of the circle. Okay. So this formula is nothing but this one. If we have something like this, okay, this is a part of a circle, this is r, this is the length l, so this is theta. So this l is equal to r into theta, but theta must be in what? Radian. So that is what we are doing here. If we come back here, that is what we are doing. So r is multiplied by the angle, but in radian. This phi, therefore we are doing this, changing this phi, the value that is in degree. Therefore we are multiplying it by pi by 180 degree, so that it gets converted into the unit radian. Fine. So then we will get our value. So this is the straight line, this is the curved portion. Now, because the chainage of T1 point was given, we can find out the chainage of T2 point. Here, the chainage was given. That means what is the value of this carrying out survey work? What is the distance from here? We can know 1/8 something was there. We just have to add the length of this curve so that we will get chainage of T2, right? Why? Because the road will be going along this way only. The road was coming here. From T1, we have the starting of the curve and it ends at T2. So we have to add the length of this curve to get the point T2, the chainage or value of the T2 point. So we got this value. Now we have to find deflection angles to establish different points on the curve. Now we have established this T1 point. We know this T1 point. We know at some distance, we know this length, okay? We know this intersection point. So let's say this is intersection point is B point. So we know, okay, we can join this line. It can goes this way and it came this way. This angle is phi, that is the deflection angle. So this much information we have. This point is T2. Now how these points will be selected, the points on the curve. Okay, for that we can find out some deflection angles. So deflection angles from where? From this line, okay? Depending upon the chord length. So what we'll do, we have this total length of the curve, which we will divide suitably. Okay, 20 meter, 30 meter, 50 meter, something like that. We will divide the length of the entire circular curve into suitable divisions, and there we will find out deflection angles. Say for example 20 meter. So if we go 20 meter along this direction, what will be this angle? So that is our delta 1. Okay, we will find that value. If we know that value, we can have some instrument of angle measuring, and we can give that angle here from this point, and we can look along this side, and we know this distance, and we got this point, right? And then say for example, the next is another 20 meter from this point. Okay, so now how much it is deflecting? So this deflection is here, delta 2. Okay, small delta 2. So you go in this direction 20 meter. The direction is given by the angle delta 2, and we get the point, second point on the curve, right? Similarly, now we are looking here and we want to go another 20 meter. In which direction? In the direction of delta 3. So we will find out this delta 1, delta 2, delta 3 with our formulas, just looking at how it is done. And we will find out the next point on the curve. okay, this way. Or what we can do, this delta 1 and delta 2, if we add them up, say we say there is another set of data like this. Capital delta 1 is equal to small delta 1, capital delta 2 is equal to small delta 1 plus, sorry, yeah, capital delta 1 plus small delta 1. Then delta 3 is the capital delta 2, the other value, plus the next small delta 3. Okay, like this. So we are taking the cumulative values. If we do that, so delta, small delta 1 and small delta 2, if we add them up, we will get another angle. Okay, this angle we will be looking towards here, this way. So what I'm saying, the first value was delta 1, the second value was delta 2, the third value is small delta 3. These are small deltas. They are being taken here. The next one is here. The next one is here. If we do that, what we have to do, we have to change our equipment at every position. So we are here. First one, when we are measuring this small delta 1 and we got the direction, we went some meters in this way, 20 meter, 30 meter. We got the second point, then the instrument will have to come here. And then again, we have to find out the next delta 2, go the direction 20 meter. Then again, the instrument will have to come here. Then again, we have to go in this way, find the direction delta 3 and go in this way. So that way we have to change our instrument every time. So what we can do, we can do it this way. We have this T1 point here. We have this intersection point here. And we have the T2 point here. So what we can do, our instrument stays here at T1 only. We gave the first angle, delta 1, and we go 20 meter along this way. Okay, we got the first point. Then from here only, what we gave the second angle, delta 1 plus delta 2 this time, from here only. So there we will get the direction from here only, and the distance will be 20 meter from this point. Okay, we got the second point. Then from the third value, we gave the angle delta 1 plus delta 2 plus delta 3 from here only, and we got the direction. And then we get, okay, let's go 20 meter from this point, because we were dividing it into 20 meter. If we do it 30 meter, it will be 30 meter, or if we divide it in some other value, accordingly it will be done. So we got the next point. This way also we can do. So this way will be little more convenient, because we are not changing the position of our angle measuring equipment. We are staying at only one position, say T1, and then we are changing the angles. We are adding the angles, and we are getting the direction, and we are finding the different points. So we are writing that capital delta 1 is equal to small delta 1, and capital delta 2 is the small delta 1 plus small delta 2. Capital delta 3 is small delta 1 plus delta 2 plus delta 3, this way. Okay, cumulative increment, or this small delta 1, small delta 2, we can write capital delta 2. So that way we can carry out our angles calculation. Now, here, what we are doing here, see the chainage here. Okay, the chainage was from 1804.25 to 2083.5 meters. From this chainage, we have to go to this chainage. Okay, this is a T1 point, this is a T2 point. So what we are doing, we want to take the measurement at some suitable values. So this is not exactly necessary, but we are doing it, okay, here. Like we want to take the angles at 1820 meter. The next one we want to take at 1840 meter, 1860 meter, 1880 meter, next at 1900 meter. then 1920 meter. Like this, we are going on adding. So most of our codes are 20 meter. Okay. But the first one and the last one will be different. So it was like this. This was the curve. We know the length of the curve, right? We know the length of the curve. We have to divide it in suitable chords like this. Okay, like this, we have to divide in suitable number of chords. And most values are 20 meter. These are 20 meters. But the first and last is different because what we want to do, we want to find these points in some this type of numbers. This Chinese is 18.20 meter. Next Chinese is 18.40 meter. Now this is not absolutely necessary. This, looks good, or it is better to point those, mark those points because it has a number like this, but this is not exactly necessary. We can do at any point if we want. Then going back, so what will be the C1? What will be the first? Because we are finding out the first point at 18.20 meter. So therefore, what will be the length of the first chord? We know this chain is, this was 1804, and this we want to find out at 1820 meter. So what will be the length here? This minus this. Okay, something like 16 meter. The next one we are taking 20 meter, 20 meter, 20 meter, 20 meter, and the last one will be different, whatever is remaining. So the first one is, you see here, 1820 meter minus 1804.25 meters, so 15.75 meter, the first chord. Then all the intermediate chords, there are 12 sub chords intermediate, which are 20 meter each, and we get to the chainage of 2060 meter. And there what we do, from there we see what is happening. If we take 20 meter under, there will be a very small chord, 3.5 meter left. So what we are doing, we're taking the last chord, 20 meter plus the extra. Okay, if we come 20 meter, we will reach 2080 meter. 3.5 meter is extra, so we are taking that also. So 23.5 meter is the last sub chord. Then this is our formula. So this formula, we have to remember it, 1718.88, but we will do 1719. Okay, we can round it off, 1719. This is the chord length that we are assuming, and this is the radius of the curve. So this will give us the deflection angle in minutes. Okay, so the first one, the C1 was how much? 15.75. 15.75, right? 15.75. So what we are writing 15.75 here, divided by 400. That is the radius of the curve, right? C1 is in meter, R is in meter. So done. So the value is coming in minutes. So 67.6809 minutes. We will convert it to degrees, minutes, and seconds. We will just use our scientific calculator and we will convert it into degrees, minutes, and second. Then the next, all are 12 chords, right? Delta 2, delta 3, delta 4, delta 5, up to 13, because the next 12 is, the length of the chord is same, 20 meter only. So all those values are going to be same. 1719 into 20 divided by 400. If we do and convert it into degrees, minutes, and seconds, this is our value. Then the last value will be different. So last value is delta 14. So chord length is different here, 23.5 meter, and we have a different value. Now, what will be the deflection angles to be given from T1 point? So we know that we have to add the values, cumulative values. So capital delta 1 is small delta 1, capital delta 2 is capital delta 1 plus delta 2, just now, just like we saw, okay? So that way we will prepare all the angles. Let's come here in this table. So we will prepare a table like this. So we have these points. These are the points on the circular curve that we have to find. These are the chord length. Okay, the first one, distance from the T1 point, 15.75 meter, 10, 20 meter, 20 meter, 20 meter, 12 number of divisions are there, and the last one is 23.5 meter. The tangential angles we have already calculated, or also called deflection angles. This is the total deflection angle from T1 point. So here what we are doing, we are adding up. The first one is this value only, 1.07 1 degree 07 minute 40 seconds. The next one we will be added 1 degree 07 minute 40 seconds plus this 1 degree 25 minute 56 seconds. We got this value. Then the third value will be what? This second value, delta, capital delta 2 plus the small delta 3. That will be added, and this will be our resulting deflection angle to be given from T1 point. Okay, this way we can go on just adding up. Then what will be the theodolite reading? If we are using a theodolite for measuring the angles, what will be the theodolite reading? In this numerical, there was no list count of the theodolite was given, so we are keeping the values as it is, assuming that we have a list count of 1 second. But if the list count of the theodolite is given, say for example 20 seconds is the list count of the theodolite, it is given, then these values will change. Okay, so this is 40 seconds. Whenever it is 20-second list count, we have to know that we can give 20 second, we can give 40 second, then we can give 60 second or 1 minute. Next minute it will go, right? That way only the angles can be given in the theodolite. So this 40 seconds can be given, so it will be as it is. Here we have 37 seconds at the last value, so we cannot give 37 seconds. If the list count is 20 second, we can either give 20 second or we can give 40 second. So we will see this 37 second is nearer to which value? Is it nearer to 20 second or is it nearer to 40 second? It is definitely nearer to 40 seconds. So this value, the theodolite reading that we will be providing, will be changed into 2 degree 33 minute and 40 seconds. Done. The next value we have 34 seconds. Again, this is closer to 40 seconds, so this will be changed to 40 second. 31 second, closer to 40 second, it will be changed to 40 second. 28 second, closer to 20 seconds, so this will be changed to 20 second. That way we will have our theodolite reading according to the list count of the theodolite. Now this is the distance from T1 point. So this is just addition of the chord length. First one is 15.75 meter. The next one is 15.75 plus 20. That way we will also be getting the distance from the T1 point. Okay. So few lines are not completed. That is for you to complete. So again, we'll see once quickly that what we will do. First, we will have this T1 point. We will know this point because the road is coming from here, right? We know from here, we have to start a curve. And we have from design, okay, the radius of the curve, etc., will come from the design. That we will see later in transportation engineering. Okay, what is the width of the road? What is the speed of the vehicle that will be traveling on that road? Based on that, we will have this design. So what will be the radius, etc. So if it goes straight, it is this way. The curve should meet here, T2 point. We can measure this distance, right? It is the intersection point, say for example, if we connect, it is like this. The road is going here. The road was coming from here. And what we will do, we have a theodolite at T1 point, and we are looking towards B point. The angle is 0, 0. The first will be, delta 1. We are looking along this side. And what is the chord length? 15.75 meter. We reach here, 15.75 meter. So this is our first point on the curve. Next angle that we will give, delta 2. and we are looking along this direction. Now, what is the distance from this point? It is 20 meters. We got the second point. Then we give the angle, the third angle, delta 3. We are looking along this direction. Again, from this point, 20 meters. Okay, and we got the third point. So this way, finally, when we connect all the points, we will get the curve, how it should come. So then again, we have another numerical. Here we have a curve, 300 meters. Now this we are asked to set out with 2 theodolite. In the earlier one, we were using only 1 theodolite or only 1 angle measuring equipment that was either at T1 point or T2 point. Here we are using 2 theodolite. Deflection angle of the curve is given. We have to tabulate these readings. Here we are given least count of the theodolite is 22nd, and we are assuming that both the theodolites are turned clockwise. Okay, we'll see. And change of tangent point is given. So basic data is radius and deflection angle, those are given. If those are given, we have formulas. With that formulas, what we can do, we can find out the length of the long chord. Remember the straight line between T1 and T2 point. We can also find out length of the curve. We can also find out the change of T2 point, because change of T1 point is now given and length of the curve is now known. We can find out what will be the change of T2 point. Then we will see that we have to go from where 1083.65 meter to 1272.15 meter we have to go. So we are saying that we will find the points at 1100 meter, 1120 meter, 1140 meter, like that. So what will be the first chord length? 1100 meter minus this value. So this distance we have to take 16.35 meter. Then only we will get this point. So T1 point is at 1083 meter, right? Similarly, same case. This T1 point is known, okay, change is known. It will go along this way somewhere. We don't know how exactly at the moment. So this change is 1083 meter. So how much we have to come in this way to reach a point where this value will be 1100 meters. So that is what we are finding out. This is the first chord length. Then we will go 20 meter, 20 meter, 20 meter, 20 meter, like this. And the final value we will see whatever is remaining. So coming back, so the first value C1 is 1100 minus 1083.65 meter. So we got this first chord length. Then we have 1100 meter, 1120 meter, 1140, 60, 80, 1200, like this we are going, and we have 8 subchords of 20 meter in this range. Then the last one, we see that from 1260 we have to go to 1272. So last value remaining is 12.15 meter. So there are no hard and fast rule in this. We can divide this suitably. Then we have the same formula, finding out tangential angle. Delta is 1719 into chord length divided by radius. The value will be in minutes. So we are finding for C1 16.35 meter. What is the tangential angle? The next 8 values will be same because the chord length is 20 meter for all the cases. So we got the value, and the last one is again different, 12.15 meter. So last value is different. So what we are doing, again making this table, 0.1, 0.2, like this. We have first chord length is this one, then we have these intermediate chord lengths of 20 meter, and the last one is different. These are tangential angles, then deflection angle. So what we will do here, we will add up. First deflection angle is same as this tangential angle. The second deflection angle is what? The first value added to the next tangential angle. Capital delta 3 here is equal to this value delta 2 plus small delta 3. So that way we will have cumulative values we will have on this column, okay? Because we are adding the angles and we are providing the angles from one point only. Now we have theodolite of least count 40-second. So the first value is 40-second, so no issue. 40-second only, sorry. Least count of the theodolite is 20-second. So here we have 16-second. So either we can give 0-second or 20-second. So here it is closer to 20-second, so the value will be 20-second. This is 52, it is closer to 60-second, then 40-second. So this value will be 60-second or the next minute. It should have been written as 5 degree 23 minute. Okay. So this way we will have the theodolite readings. Then again, what will happen? We will know this T1 point. We will know this T2 point. We will know the intersection point as well. This is how it deflected. The curve will be in between here. So what we will do, we have one theodolite here and another theodolite at this point. So this theodolite will be looking at B point. The value will be at the first 0, 0. Then we will give an angle equal to delta 1. Sorry, capital delta 1. Here also we will have one theodolite looking at this B point. The value is 0, 0. And the first value, this theodolite T2. This theodolite T2, this is theodolite 2. This will be here at T2 point. It is looking at T1 point. Okay. And from here, we will give an angle delta 1. So this is here. This is delta 1 here. And this is here. This is delta 1 here. The intersection of these two directions will give us the first point on the curve. Then the next angle will be delta 2. And from here also, we will have the next angle delta 2. The intersection point will give us the location on the curve. Similarly, the next delta 3, this point. Okay. So this way, we will get the different points on the curve by two theodolite method. So in two theodolite, we are here at T1 point, looking towards B point or the intersection point, giving angle delta 1, delta 2, delta 3 like this. And the theodolite 2 is here at T2 point, looking at T1 point. And then we are giving angles delta 1, delta 2, delta 3 like this. So both these are operating clockwise. So T1, the angles are going this way. At T2 also, what is happening? The angles are provided this way. So both are operating in clockwise direction. That was also the condition of the question. And the points on the curve is given by the intersection of the directions given by both the theodolites. And then we will find out the points on the curve. We will connect them and we will have the curve between T1 and T2 point.